Welcome. Today, we're diving into the world of webhooks, a powerful mechanism for enabling real-time communication between different web applications. If you've ever wondered how apps instantly notify each other when something important happens, like a payment confirmation or a new code push, webhooks are often the magic behind the scenes. In this video, we'll explore what webhooks are, why they're sometimes called reverse APIs, and how you can implement them using Java and Spring Boot. Whether you're building integrations, automating workflows, or just curious about event-driven architectures, this guide will walk you through the essentials, step by step. Start with the basics. What exactly are webhooks? Webhooks are user-defined HTTP callbacks that allow one application to send real-time data to another whenever a specific event occurs. Instead of your app constantly checking for updates, the provider notifies you instantly by making an HTTP request, usually a post, to a URL you specify. This approach is widely used for integrating systems, automating workflows, and building event-driven solutions. For example, when a payment is completed or a code is pushed to a repository, the provider can immediately inform your app by sending a payload to your webhook endpoint. Webhooks are often referred to as reverse APIs. Why? Because, unlike traditional APIs where the client repeatedly polls the server for updates, webhooks flip the script. The server proactively sends data to the client as soon as an event happens or processing is complete. This means your application can react instantly to changes, without unnecessary network traffic or delays. It's a more efficient and responsive way to keep systems in sync and automate processes across platforms. Understand how webhooks work. Let's walk through their typical lifecycle. First, the consumer application registers a public URL with the provider. This is the webhook endpoint. Next, when an event occurs in the provider system, such as a new commit or a payment, the provider immediately sends an HTTP post request with event data to the registered endpoint. The consumer receives this payload, processes it, and can optionally send a response back to acknowledge receipt. This flow ensures your application reacts to external events as soon as they happen. First step in the webhook lifecycle is registration. Here, the consumer application tells the provider, like GitHub or Stripe, where to send webhook notifications by registering a public URL. This endpoint acts as the listening post for all incoming webhook events. It's crucial to ensure this URL is accessible and secure, as it will receive potentially sensitive data from the provider whenever relevant events occur. Once the webhook endpoint is registered, the next step is waiting for an event to occur in the provider system. This could be anything from a new user being created, a payment being received, or a code commit being pushed. The provider monitors for these events and is ready to notify the consumer as soon as something happens. This event-driven approach is what makes webhooks so powerful for real-time integration. When the specified event occurs, the provider immediately triggers the webhook. This means it sends an HTTP post request, usually containing a JSON payload with event details, to the consumer's registered endpoint. This instant notification allows the consumer application to react in real time, updating its own state or triggering further actions based on the event data received. Once the consumer's webhook endpoint receives the post request, it processes the payload. This might involve updating a database, sending a notification, or triggering other workflows. The consumer can handle different event types in various ways, ensuring that each event is processed appropriately. This flexibility is key to building robust, event-driven applications. After processing the webhook payload, the consumer endpoint can optionally send a response back to the provider. This response typically acknowledges receipt of the webhook, letting the provider know that the event was successfully handled. While not always required, sending a response can help with reliability and debugging, especially in complex integrations. Now let's see how to implement webhooks in Java using Spring Boot. Both the provider and consumer will be Spring Boot applications. To get started, you'll need to add the Spring Boot Starter Web dependency to your project. This provides all the necessary tools for building REST-TFL web services and handling HTTP requests and responses. The consumer application is responsible for exposing an endpoint to receive webhook notifications. In our example, we'll create a simple record to represent the webhook payload and a controller to handle incoming post requests. For now, we'll just log the payload, but you can expand this to process events as needed. To handle incoming webhook data, start by defining a record class for the payload. In Java, this might look like public record webhook payload, string event type, string message. This structure makes it easy to deserialize the incoming JSON and work with the event data in your application. Next, create a controller in your consumer application to handle post requests to the webhook endpoint. This controller receives the payload, logs the event, and processes it based on the event type. For example, you might handle user-created and user-deleted events differently, ensuring each event triggers the appropriate logic in your system. Inside the Webhook controller, use logging to track incoming events and their headers. This helps with debugging and monitoring. Then, use a switch statement or similar logic to process each event type accordingly. For example, log a message when a new user is created or deleted, and add custom handling as needed for your application's requirements. On the provider side, you'll need to send webhook notifications to the consumer whenever an interesting event occurs. This involves creating a service to send HTTP post requests and a controller to trigger these events. With Spring Boot, you can easily set up both components for seamless integration. To send webhooks, create a service in your provider application that uses Spring's REST client. This service constructs the payload and sends an HTTP post request to the consumer's webhook endpoint. Proper error handling ensures you know if the webhook was sent successfully or if something went wrong. Add a controller in your provider application to simulate events that trigger webhooks. For example, you might have endpoints like trigger create event and trigger delete event that call the webhook service with different event types. This setup makes it easy to test and demonstrate your webhook integration. Here's how the complete flow works. Start both applications, with the consumer listening on one port and the provider on another. When you trigger an event in the provider, it calls the webhook service, which sends a post request to the consumer. The consumer receives and processes the payload, and you'll see log messages confirming the webhook was handled. This end-to-end flow demonstrates real-time, event-driven communication between two systems. Webhooks are used in countless real-world scenarios. For instance, payment gateways use webhooks to notify your app when a transaction is completed. Version control systems like GitHub use them to alert you when code is pushed or a pull request is opened. This pattern is essential for building integrations that need to react instantly to external events. When implementing webhooks, security is crucial. Always validate incoming requests to ensure they come from trusted sources. Use secret tokens or signatures to verify authenticity, and consider using HTTPS to encrypt data in transit. These steps help protect your application from unauthorized or malicious requests. Handling errors gracefully is important in webhook integrations. If a webhook delivery fails, consider implementing retries with exponential backoff. Log errors for monitoring and debugging, and provide clear responses to the provider when something goes wrong. Robust error handling ensures your integration remains reliable even when issues arise. Testing is a key part of building reliable webhook integrations. Use tools like Postman or custom scripts to send test payloads to your consumer endpoint. Monitor logs and responses to ensure everything works as expected. Automated tests can help catch issues early and keep your integration robust. As your application grows, you may need to scale your webhook consumer to handle more events. Consider using message queues or worker threads to process events asynchronously. This approach helps maintain performance and reliability, even under heavy load. Effective monitoring and logging are essential for maintaining webhook integrations. Track incoming requests, processing times, and errors to gain insights into system health. Use centralized logging and alerting tools to stay informed and quickly address any issues that arise. Follow best practices to ensure your webhook integrations are robust and secure. Use unique endpoints for different event types, validate all incoming data, and implement proper error handling. Regularly review your integration for improvements and stay updated with the latest security recommendations. As you gain experience, explore advanced webhook features like retry policies, event filtering, and batching. These enhancements can improve performance and reliability, especially in complex or high-volume systems. Tailor your webhook implementation to fit your application's unique needs. Good documentation is vital for successful webhook integration. Clearly document your endpoints, expected payloads, and response formats. Provide examples and troubleshooting tips to help users get started quickly and resolve common issues. The world of webhooks and event-driven architectures is constantly evolving. Stay informed about new features, security updates, and best practices by following relevant blogs, tutorials, and communities. Continuous learning ensures your integrations remain effective and secure. Wrap up, webhooks are a powerful pattern for building event-driven integrations between applications. With Spring Boot, creating both a webhook provider and consumer is straightforward. Remember to focus on security, error handling, and scalability as you build your solutions. By following best practices and staying informed, you can create robust, real-time integrations that power modern software systems. Thanks for watching. For more in-depth tutorials on Java, Spring, and modern software development practices, be sure to explore additional resources and guides. Stay tuned for more content on the latest in AI and software engineering, and keep building amazing integrations with Webhooks and Spring Boot.